Hello and good day. I hope you are doing well today. In this video, we are going to discuss about coal gasification, a process which is very critical due to its pressure, temperature, and coal in the powder form. So let us start. Here, as you can see on the screen, we have a schematic diagram of the coal gasification process taken from Chiyoda Corporation website. Here, the input is cheap coal which goes into a gasifier along with oxygen at 35% of the total value and steam. If air is used in the process, then we get a product that is producer gas where nitrogen content is very high, while if oxygen is used, then we get synthetic gas. The gasification process will have a temperature of around 1200 degrees centigrade to 1500 degrees centigrade. The first chemical equation is carbon along with oxygen and water or steam converts into hydrogen and carbon monoxide, that is CO. In the second stage, where there is a CO shift, that is CO plus H2O will give us CO2 and H2. Here, what we will do is that CO2 separation will be done in a separate unit, as you can see in the diagram, and H2 will be used in different processes. Finally, the product that we get is synthetic natural gas, that is syngas. We get sulfur, which can be used to make sulfuric acid, and we have ash, which can be used for other purposes. Let us go in detail now. Here is the EFD of the process taken from Mogas Industries Inc., America. Here they have given a good presentation of what are the valves used along with the pressure and temperature. So let us see each one of them. First, coal slurry. Here coal will be in the form of powder or along with water it is injected into the pump. Here the temperature is 93 degrees centigrade, pressure is 34.5 bar and size of the valve can be 10 inch to 16 inch. Typically a ball valve with metal seated live loading packing can be used. Second, oxygen service valve. As we discussed earlier that oxygen is used as an input to the process, oxygen valve is required. Here the temperature is 260 degrees centigrade, pressure is 206.8 bar, size of the valve is 2 inch to 4 inch and here also a metal seated ball valve is required. Third, gasifier inlet. Here the coal slurry which is being pumped through is being heated initially to a temperature of 650 degrees centigrade. The pressure is same, 34.5 bar. Size is also same, 10 inch to 16 inch. Here also a metal seated valve is required. 4 and 5, hopper inlet and outlet valve. These valves are used for collecting the ash from the gasifier. Temperature is 650 degrees centigrade, pressure is 34.5 bar and size is 4 inch to 12 inch. Here again a metal seated ball valve is required. Also the design has to be special to take care that the powder or the ash is not being collected in the cavities of the ball valve. 6 and 7. These are purging nitrogen valves, both on the inlet and the outlet side. The temperature, pressure is same. Size can be 2 inch to 4 inch. Metal seated valves. Gasifier outlet. Pressure and temperature remain same at 650 degrees centigrade and 34.5 bar. However, size is reduced a little bit, 8 inch to 14 inch. Here also a metal seated ball valve is there. 9. Syngas cooler. Here, as the gas is removed from the gasifier, it is cooled through a cooler. The temperature is reduced from 650 to 150 to 260. Pressure is also reduced from 34 to 13.8 to 20 bar. Size increased little bit, 10 inch to 16 inch, and here also we require a metal seated ball valve. 10 and 11. Here, whatever the particles are there, they are again sent it to the gasifier, that is charge recycle, and there is a filtration system where these two valves are used. Temperature is increased slightly before they are sent into the gasifier and in the filter. So temperature of 260 to 480 degrees centigrade. Pressure will be 13.8 to 20.6 bar. Size will be 4 to 8 inch metal seated valves. 12 and 13. These are scrubber and hydrolysis valves. Temperature will be 150 to 200 degrees centigrade. Pressure will be 6.9 to 13.8 bar, and size will be 14 to 18 tunnel mounted ball valve. Here the gas is much cleaner because the char particles are being removed. The filtration valve has removed all the residue. So here you can use a tunnel mounted ball valve. 14 will be sour water. Temperature will be 150 to 200 degrees centigrade. Pressure will be 6.9 to 13.8 bar, and size will be 8 to 14 inch tunnel mounted ball valve. Because it is cleaner, the media is much cleaner, so that is why we are using a tunnel mounted design in this case. In the first part we have seen that how synthetic gas is produced, while in the second we will see how it is being treated to remove all the residue impurities and make the gas suitable for commercial use. So valve number 15, 16 and 17, the temperature is reduced further 28 to 93 degrees centigrade. Pressure will be 6.9 to 13.8. Size will be 14 to 8, and tunnel mounted ball valve will be used. Here 18 and 19, the temperature is 150 to 200 degrees centigrade. Pressure is same. Size is 18 to 12 inch, and here also a ball valve with metal seated is required. Next, tail gas compressor valve. The temperature is 38 to 93 degrees centigrade. Pressure is increased to 34.5 bar. Size will be 4 to 8 inch, and here we can use a tunnel mounted ball valve. This is a clean gas, but this gas will go into the gasifier for commercial process. Next is 21, 22 and 23, which is sweet syngas, moisturizer and heater valves. Here the temperature is 38 to 93 degrees centigrade. Pressure will be 6.9 to 13.8 bar. Size will be 14 to 8, and a tunnel mounted ball valve is used. As you can see here in the two slides that we have discussed, that the pressure fluctuation is from 6.9 to 34.5 bar, while the temperature fluctuation is from nominal 38 degrees centigrade to 650 degrees centigrade. Mostly metal seated ball valves are used where coating is very critical on the ball, which gives the sealing at very high pressure and temperature. Some of the companies like Mogas, they have developed many coating for the ball using chrome carbide, tungsten carbide, and even they have a patented coating that they are using for such very critical processes. One point which I want to emphasize further is that when you select a valve manufacturer for such application, try to make sure that what is the research and development done in the coating area. Because imagine that you select a valve and the valve is in the process with such high pressures and temperature and the valve fails. It will be a disaster and a lot of loss. So try to see what is the experience of the valve manufacturer for such critical processes. Let us see what are the valve challenges in this process. First, HSE challenge, that is a valve leakage may lead to chances of fire and are toxic. So we have hydrogen here and we have carbon monoxide. So imagine if this been leaked to the environment, it will create a lot of problem. So this is a real challenge for the valve. Second, product quality. As I discussed earlier that there is a huge temperature fluctuation in this process. The process must be stable to give you a product quality, and that is only possible that if you have the valve with very high reliability. Third, maintenance. Due to this process, it requires frequent maintenance within 2 to 3 months. Hence, there is always one unit then required, so that when two are operating, the one is under maintenance. Customer is actually looking for longer runtime of the unit itself, so by reducing the production losses. Thank you. I hope you like my small presentation on this process. Before we leave, I just want to highlight our services to you. We are doing supply of valves, design packages of valves, casting forging, both in the raw material form as well as machine form, supply of valve component and spare, and we are doing valve factory setup and certification consultant and training. So in case if you require any of these services, please contact. Thank you.